Hey everybody, welcome back. Thanks for joining me once again in Unreal Engine 5. Today I have a quick but very helpful video if you're using physics in your game. It's going to show you how to enable substepping, which will smooth out your physics and help them run more accurately at lower frame rates. So let me jump into Unreal Engine and show you what I mean. This video is going to be very helpful for those who are following along with a previous video or two I made, how to make a ball roll, jump, and dash using physics. I found that when I tested my game on a much older, slower PC, that's when it was revealed. It was like, oh yeah, these physics calculations are being hammered out on a frame rate. And so if the frame rate dips, my ball moves slower, behaves differently. So let me demonstrate that problem to you, and then I'll show you how to fix it. If we go over to the side, we are able to show our FPS. So I've clicked that, and you can see on the right hand side there it's hovering between 100 and 120. So press play on the game. This is how I expect my ball to move. And I'm going to grab the controller because this camera movement is also going to come into play. Okay, so at about 100 to 120 frames per second, we're getting movement that looks like this. Now, if you go up into your project settings, type in the word frame rate, we'll get access to the few areas I want to adjust. Down here under Engine General Settings, you have the option to use a fixed frame rate. I have selected that and set it to 120. And changing this will enable us to test our game at different frame rates. So at 120, it played the way you saw it. I have substepping enabled, so I'm going to deselect that. And you'll see it's almost as easy as just selecting substepping and a few other things to take care of, and then you're good to go. But let's drop it down to, say, 30. And I'll show you. Again, I'll try to use the controller. So the camera is turning slower now. It used to be pretty whiplash. The ball is sinking into the water a bit more. Ultimately, it should be moving fairly similar because it can handle 30 frames per second. But if we get below 30, I could try to put in 10, but you'll see that 15 is, I think, the minimum there. This is when it's really bad. So now my camera is really slow to move, and my ball is not moving anywhere near what it's supposed to be doing. The buoyancy is not as responsive. So if you're playing your game on an old PC with a low frame rate, you're going to experience this. So how do we fix it? Let's leave it at 15. Oopsie. But now we're going to enable substepping. This is in the engine physics part of your project settings. And you'll notice that the max physics delta time, this is set to 1 over 30 frames per second. That's what 0.03333 is. So that's why our game still looked okay at 30 frames per second, but as soon as we dip below 30, it started to behave different. So if I enable substepping, that max delta time is now grayed out, and we're going to use a max substep delta time and a number of substeps. So I've found that the default settings work just fine. This is 60 frames per second, and this is going to do 6 substeps at that rate. So with these settings applied, let's have another look. Now the ball is behaving as we might expect it. However, the camera is still slow. So that's why it's not as simple as just clicking substep. You have to do a few other things. But you notice the difference now. At least the ball is moving at 15 frames per second, the ball is moving the same as it was at 120. So how do we fix the movement? So I've come here to this look function, and we're going to add a few components to this. So the reason why this movement system isn't working in the same way, this look system isn't working in the same way that this move system is when we add substepping, it's going to affect all of these types of nodes, the add force nodes and the add angular impulse, all of these ones it's going to affect, but we don't have that up here. We have add controller pitch inputs. And so that is calculating on a frame rate. So if we're doing 15 frames per second, this is calculating at 15 times per second. This is making use of our substepping, doing 6 steps in addition, a maximum of 6 steps between each tick of the frame. So how do we do this? We're going to use a node called get world delta time. Seconds, rather. Get world delta seconds. And we're going to create 2 new variables. Floats. I'm going to call it base turn rate. Set it as a float, compile it, and then the default we're going to set to 90 as a start. And this is going to be the variable that we could expose and make available in our settings menu if we wanted, so that the player can tweak this, so they can adjust how fast they want the camera to move, which is something I'll probably do in my own game. But we need a second one as well, and this will be base look up. Base look up rate. Same thing, compile it and set it to 90. Boom, boom, boom. So go ahead and grab these. You're going to multiply the base turn rate. We're going to multiply, here, I like to put this in the bottom. The action value times get world delta. Let's give us some more room here. Pull this down here. So we're going to multiply the action values by this, and then multiply the output of that by this. So let's do y first. And then multiply that by this. And then the output is what we're going to feed wherever this action value was going before. So down here, looks like it's going to the pitch input. So let's feed it into the 2 pitch inputs. And we have 2 for reasons I won't get into now, but there. Now we have to deal with the y action value, which is the exact same, but we're going to use this base lookup rate. Let me just duplicate this. Bump, bump, bump. There we go. Output of this goes there. And this is coming here. And wherever that X was going, it's going over to this one and to this one. So without making it tidy, let's test it. Remember, we're at 15 frames per second and our ball is moving fine. And now our camera is also moving fine. And if we wanted it slower or faster, we could change those variables to something other than 90. One other thing to note is if you go to the viewport of your ball, your player ball, or whatever the physics asset is, your pawn, and you go to the mesh, the main mesh that's going to be interacting with your world. And check out the CCD. This is continuous collision detection. So I had to turn this on. I'm going to turn it off and show you what that does. It's most noticeable at 15 frames per second. You're going to start punching through meshes. I hit through 2 in a row there, for example. What's happening is the ball is now doing substepping, and it is calculating its physics and updating more frequently than the other meshes in the game, which are being rendered at 15 frames per second. So what you have to do is turn on continuous collision detection. That is going to, instead of waiting for that ball sphere to hit something, it is going to project outwards from it. A bigger shell, I suppose, is one way to describe it, and sense things before the ball gets there, so to prepare it for the collision detection. So let's go back and change. I have a water collision sphere that I'm also turning it on for. There we go. Just a real quick to show you now where we were punching through those spheres. Now we are going to just bump up into them. Or bump off them, I mean. Great. So now you have a system that is going to run, should run about the same. The physics are going to run the same at any frame rate, which is very relieving, something I was avoiding doing because I thought it was harder than it is. Review the steps. We are going to use whatever frame we want. I'm going to put it back up to 120. Down in engine physics, select substepping. The default settings seem to work great for me, but you can increase the substeps if you want to, say 8 or 10. And you could change this max substep delta time as well if you like. After doing that, come back to your mesh that is the one of concern, and then turn on continuous collision detection. If you have any other events in your Uber graph that you notice being affected by low frame rates, you can use the node called getWorldDelta seconds and then multiply the action value by that and some other variable to get a more consistent experience at different frame rates. And I believe that's the only one I had to do that for. Everything else uses force nodes, and those are handled automatically by the substepping system. There you go. I hope this video was helpful. If you're using physics in your game, be sure to consider substepping. It will have a slight performance trade-off, but it's better than having your game behave totally differently at different frame rates. So this is one way to make your physics frame rate independent in a kind of a way. All right, thanks for joining me. We'll talk to you later. Bye.